88, graphing and solving linear inequalities. Again, I feel like this is probably something that's been covered. If not in this class, then you've hit it, you've seen it at some time. So it's going to be some redundant information. Hopefully we get through it really fast because I have like one battery left on my mic and I'm out of AA batteries. So a linear inequality can be rearranged just like a linear equation. The only difference is that multiplying or dividing both sides of the inequality by a negative number changes the direction of the inequality sign. To solve a linear inequality, you convert it to slope-intercept form. So essentially, you solve for y. And if you end up having to divide by a negative, you change the sign. Other than that, it solves exactly like any other type of linear equation. We're just adding an inequality symbol to it. Okay? The graph of an inequality includes points that are not on the graph of the linear equation. A region of the coordinate grid bounded by the graph of the linear equation is shaded to show the points that satisfy the inequality. Right, so it's shaded, right? We're going to show which side of it we're going to shade. For inequalities where the y values are greater than the y values of the line, we're going to shade the region above the line. For y values less than y values on the line, we're going to shade the region below the line. And that is, well, we got one more thing. When the inequality uses greater than or equal to, less than or equal to, the graph includes the line itself, so the line is solid. For inequalities that use just greater than and less than with no equal sign to it, the graph does not include the points on the line, so we've used a dashed line to show that the line is not included with the shaded region. Okay, it's not part of the solution. And that's it for that, which means we're going to dive into some questions. All right, so we want to graph an inequality. We have y is less than negative 1x minus 3. So the negative 1x minus 3, that's my slope-intercept or my y-intercept form. Okay? What should be the y-intercept of that equation? What number in there represents where I'm crossing the y-axis at? Negative 3. All right, so does graph A work for that? No. Does graph C have the correct y-intercept? It doesn't have the correct y-intercept? I'm not asking if the graph is correct. I'm just asking, does it cross the y-axis at the right spot? Yes, it does. Okay? All right, let's go see if we can eliminate anything else. Now, does B and D, do they cross the y-axis at the correct point? Sure. All right, the next thing I want to look at after the y-intercept is I want to look at the slope. All right, what kind of slope is that? It's a negative slope. So what should I notice about the line from left to right? It should be going down. Should be going down. So does that, we already eliminated A because it had the wrong y-intercept. Can I eliminate C for the wrong slope? Yes. So we're coming down to B and D. Do both of them have negative slopes? Do both of them appear to have slopes that go down 1 over 1? Right? So they both have negative 1 slopes. So what's the only difference between B and D? The dotted line or the solid line? All right, so we're going to go back and we're going to look at our inequality. All right, what should it be? Should it be dotted or should it be solid? Dotted. How do I know it's dotted? Because it's not equal to. So as I go down here to question number 1, right, which one is the correct answer? D. Right, we want that guy right there. Okay? All right, pretty easy stuff. All right, let's come on down here. All right, so you notice that this first one, is it in slope-intercept form? Yay or nay? Nay, okay. So we need to convert this to slope-intercept form. Slope-intercept form means that I'm solving for what? Y, right? Correct? All right, so what's the first thing you would do in trying to solve for y? Distribute the 2/3. So rather than rewrite the question, let's see if I can kind of buy some space here. All right, let's give us some room to work. So what's the first thing I should have? 2/3 times 2 is going to be what? 4 what? 2/3 times 2. What's 2 times 2? And 4 divided by 3 is 4/3, correct? So what I'm going to write is I'm going to write 4/3 x. Then what? minus 2/3 y. Very good. Is less than 2. Okay? Now, I want to solve for y. What's the next thing to do in solving for y? Subtract what? Minus 4/3 x from both sides. All right? So as I rewrite that, I'm getting negative 2/3 y is less than negative 4/3 x plus 2. Okay? What's the last thing I need to do? Divide by negative 2/3. Can I divide by a fraction? You're not wrong. I just have to change the way that I do it. Because yes, we are going to divide by negative 2/3, but what am I really doing? No. Can I divide by a fraction? Multiply by the reciprocal. Not by the opposite reciprocal, just by the reciprocal. So what I'm going to do is we're going to multiply both sides by negative 3/2. Okay? And all of this by negative 3/2. Okay, does that make sense? Okay? So I'm going to actually move this out over here so that I have, now, I multiplied by what? What kind of number? A negative number. All right, we talked about this earlier. Because it's inequality and I either multiplied or divide by a negative number, what happens? The sign switches. So it was y is less than. Now what is it? Y is greater than. You're talking about, when you talk about inequalities and solving, that's one of the very first things that is overlooked. Okay? Now we've got our sign switch. We want negative 3/2 times negative 4/3. So what's negative 3 times negative 4? 12, right? What's 2 times 3? 6. What's 12 divided by 6? 2. So I got y is greater than 2x. All right, let's keep going. What's negative 3 times 2? 6. What's 2 times 1? 2. Okay, what's negative 6 divided by 2? Negative 3. All right, so we have y is greater than 2x minus 3. Y is greater than 2x minus 3. Now, as we look at these graphs, right, you'll notice that all of them have an answer, right? So is A correct? No, because it says plus 3, right? Right? Is this one over here, this 2x minus 3, is that right? What did they forget to do? They forgot to flip the sign, right? All right, down here I've got y is greater than, that's right, 2x plus 3, is that correct? No, what about D? That's correct. Now, let's just go ahead and double check their work here on their graph. Is their y-intercept at negative 3? Yeah, it looks like a dotted line. Should it be a dotted line? Yes. Let's see, let's go up 2 over 1, up 2 over 1, up 2 over 1. Does it seem to have the right slope? Okay, so D is my answer. Okay, does that work? Do we see how all the parts come together? Okay, take it one step at a time. Let's see how many questions we actually have in all of this. 4, 5, 6. All right, so 3. Jim builds a robot that travels no more than 12 feet per minute. Okay? No more than. Which means it could be equal to, right? Graph the inequality showing a relationship between the distance traveled and the time elapsed. Is it possible for the robot to travel 19 feet in a minute and a half? So what we're saying is that y is less than or equal to 12x. Right? Is that correct? Okay. All right. Let's see. So we're talking about a minute and a half, right? Well, let's take 12 times 1.5, right? Because that's my time, correct? What's 12 times 1.5? What is it? 18. 18. So when we take 12 times 1.5, we get 18. So we're saying y is less than or equal to 18. Is it possible for the robot to travel 19 feet in that amount of time? No. It can travel up to 18 feet or less, but it can't travel 19 feet. So we're looking for options that are going to put me with a no answer. Okay, we see that A is out. C says we can't do it. Okay, let's look at what else is in here. B says we can, and D says we can't. So what do we need to look for between C and D? The graph. Okay, let's come up to C. All right, we should be able to go, let's look at 1 minute. How many feet should we be able to go in 1 minute? 12. All right, does that look correct? No. Let's go down to D and let's see where it's at 1 minute. Okay, 1 minute, 12. 2 minutes, 24. 3 minutes, 36. Does that line look correct? Okay, so we know how to find that information and check it. Okay, good. All right, let's come on down to 4. Wants us to graph this inequality. Where do I want to begin? What's the first thing I would graph? Y-intercept. Where do I want to put the y-intercept at, Matt? -1, right there. Okay? What's the next thing I would graph, Mick? Go up 5, okay? 1, 2, 3, 4, 5, then what? Right 2, perfect. Okay, but that only gives me 2 points. Is there any way to put a third point on there? Go down 5? From where? From the first one? 1, 2, 3, 4, 5, and then what? Left 2. Okay, so I've got that. Is there anything else I can do? It's a dotted line. Why? Okay, something like that. Am I done? No? I need to shade it. Now, this is, and it really should be an X there. I don't know why there's not an X there. Should be. How do I know which side to shade? The Y. The Y is the shaded zone, right? It says greater than. Okay, I'm going to give you a hint here on what is called a test plot. Have we talked about test plots before? No. All right. So do you notice this 0, 0 is on the left-hand side? Okay. So what I want to do is I'm going to plug those coordinates in for x and y. 0 is greater than 5 halves times 0 minus 1. And if this statement is true whenever I solve it, then I'm going to shade in the zone that includes 0, 0. If it's false, I'm going to shade the zone that doesn't include 0, 0. You follow me? Okay. 5 halves times 0 is what? 0. All right, so I'm left with 0 is greater than -1. Is that statement true? Yes. So I'm going to shade in the zone that includes 0, 0. Okay, and that works out really handy because if y is 0 and x is 0, that 0x is always going to cause that slope to 0 out. So I'm always comparing 0 with my y-intercept. You had a question?
No, I was just going to ask if the line happened to be on 0, 0, which side would it be?
Then typically what I do is I pick a different test plot, something like maybe like 1, 1, right? Something that's going to be easy to plug into that inequality and check. Okay, but that is a good question. His question was, what do we do if the line is on 0, 0? Okay. All right, so we've got that figured out. All right, 2 more. Let's see, 5 and 6. Solve the strict inequality 2x plus 6y is less than -1 for y. Okay, so just like probably like question number, I think it's like number 3. What do I want to do here, Miss IL? All right, so I've got 6y is less than, you say, -2x minus 7, right? You subtracted 2x from both sides. What do you do after that? Divide by 6 on both sides. All right, so do I change the sign?
Yeah.
I do? Why?
It's negative.
The 6 was negative?
No, the negative 1/3.
So you're saying because -2 divided by 6 is negative, we switch the sign?
Yeah.
Okay. No. Because I'm only concerned with how I move things across, right? And it's only a matter of multiplying and dividing. If I ever multiply or divide by a negative across, that's what will change the sign. So it is a good question to come up and a good question to ask is what are the conditions and how do I know? All right, so does that make sense now? So we should get y is less than what?
Negative 1/3 x minus 7, 6.
Minus 7, 6. Negative 1/3 x minus 7, 6. That's our answer right there. Okay? So I want to ask myself, did I divide by a negative? Did I multiply by a negative? Okay. All right. All right. Essentially, same type of question. Let's see, Aaron, help me out here. I want to solve for y. What's the first thing you do? Solve for x? Solve for y. Okay. What do I want to do to solve for y first? Subtract 6x. Subtract 6x from both sides. Okay, so I get y is less than or equal to negative 6x plus 4. Did I need to change this sign? No. Okay. Do I need to do anything else to this? No, right? It's in y-intercept form. Y is less than or equal to negative 6x plus 4. That concludes this lesson. You guys should have the next 8 minutes to work, something like that.